Well, morning, everyone. We'll have a closer look at Neo4j and Apache Hop, so future-proof data orchestration. We'll have a closer look at a brief overview of what Neo4j is for people who are relatively new to Neo4j, and then we'll dive into Apache Hop in more detail. So, quick word about Neo4j first. Neo4j, well, obviously is a graph database. A graph consists of nodes connected by relationships, and a graph database stores that graph data as a graph structure. So you store nodes and relationships in a graph. Neo4j is a property graph, and the components, like I mentioned before, is the components in graph are, first of all, nodes. Nodes represent the objects in a graph, so a person, a car, and a node can be labeled. In the two nodes in this example, person and, two instances of a person node. There's a car node, and there could be tens, thousands of nodes, well, millions, billions of nodes with thousands of labels in your graph. These nodes are related to each other. Relationships can have a direction and a type. So in the example here, the male and female person live together. That's mutual relationship, and they both have a directed loves relationship. Relationships can have a graph. They don't necessarily have one. The lives with is undirected. So two people living together share the same relationship. That doesn't mean that they necessarily love each other. One can love the other, and the love cannot be returned. So that's a one-directional relationship. And yeah, relationships connect nodes together. These nodes and relationships both can have properties. So the male node here, Dan, has a couple of properties for his name, birth date, Twitter handle, the name for the female person, and birth date as well. They are in a relationship, or they drive a car for Dan drives a car since with a property of since 10 years. Same for the N node. So these nodes and relationships can have properties of their own that enrich the information that is provided in the node and the relationship. And that combination of nodes and relationships in your graph can be queried by Cypher, which is the graph query language that is provided by Neo4j that queries your Neo4j graph database. And this is an ASCII art syntax where you match a node with a label of person, a property with the name of Dan. The same for the other node with a label of person and a property with the name of Anne, and they need to be connected by a loves relationship. So in a nutshell, this is what a graph database like Neo4j consists of, is created. And your graph will have tens, hundreds of nodes and relationships that are all connected. That are all connected through relationships. The use cases are very wide. A couple of common ones are social network analysis. That is makes sense. Everyone knows the social networks like Twitter, LinkedIn, Facebook, that are all graphs, and with the social relationships in a graph, you can start querying finding first, second, third level relationships. And that would be really hard to do in a relational database. A graph is very much suited to do this. Recommendation engines are another common one. If you know which, well, for example, which topics a person wants, well, likes to read about, it's pretty easy to make suggestions of other topics that, or other books that someone might be interested in. Search and discovery, network and data center. A computer network is a network, so is a graph in nature, and it's very well, is a very good match with graph technology. Master data management, identity and access management, well, geographical use cases, everything that you do in a route planner on a map is basically a set of points of nodes that are connected through roads, and those roads are relationships where the length of a piece of road between 2 points is a weight that you can add to the graph, and that can help to calculate travel times, etc. So that's a pretty typical graph use case as well. And actually similar to a recommendation engine, fraud detection is a very common use case as well. And an interesting, well, set of blog posts is these top 10 use cases by Jim Weber, where he goes into detail on 10 of these and a couple of other use cases where graphs really excel in. Neo4j is, well, the world's leading graph database. There are other graph databases, but Neo4j is the market leader. Neo4j actually more or less created the graph market, and was built from the ground up to work with graph structures, graph databases. Well, as the market leader already, they raised $325 million of additional investments just before the summer in June, which is the biggest investment in database technology ever. So already being the market leader, I think the future for Neo4j looks quite bright. And Neo4j can be implemented on-prem, in your own data center, in the cloud, or in hybrid approaches. And the cloud offering is Neo4j Aura. Yeah, that also has a free tier that is pretty, well, easy to get started, to start playing around with graph Neo4j technology. On top of your graph, on top of the pure database, Neo4j supports a large number of graph machine learning algorithms for community detection, similarity, proximity. So that offers an additional layer of functionality of data science that you can do on top of your graph data. Performance is an important one as well. With every release, the performance improves, so the queries that you run on your graph run faster with every release. And in combination with the announcement of the investment that I just mentioned, there was a demo where on a cluster of over 1,000 machines in AWS, Neo4j created a graph of over 1 trillion nodes and relationships that simulated a social network that was even bigger than Facebook and all the messages that have been sent on Facebook ever. And that graph with over 1 trillion of nodes and relationships had response times that were still in the milliseconds. So that's quite impressive. Well, that's Neo4j in a nutshell. What we are going to talk about today is how you get your data into Neo4j, because your data resides in or originates in a lot of systems and typically is not graph native. So you will have to get your data into a graph. There are a number of common approaches. Neo4j offers a number of tools, for example, load CSV, APOC, which are procedures that you can use to manipulate the data in your graph, but also to load data to your graph. There's a Neo4j ETL tool that translates data from a relational model to a graph and loads it into Neo4j. And then there are APIs, as the case for a lot of languages. The most common ones are Python, Java, Go, JavaScript, etc. These are a number of tools, and they work really well for very specific use cases. For example, load CSV is pretty good at loading CSV files into your database, but your data doesn't originate in or doesn't start as a CSV. So there are a couple of actions that we will have to take, and we'll have to build a data project, and that is a challenge in itself. Data projects face a number of challenges. It usually starts with a number of small scripts, individual statements to load a small set of data into your graph. But as your graph, as your Neo4j implementation grows, these things become more complicated. The scope changes, the volume of your data changes, the whole system becomes more complex, and that is when you start to run into a number of the problems that I listed here. Your data is incorrect, arrives late, the results aren't reproducible, skills are a huge problem. In a lot of cases, if you start with a small project, a number of scripts is manageable. But as your implementation grows, the people who write those scripts, need to implement new functionality and think more about the functionality that they have to implement than in terms of a bigger picture. Deployment testing becomes harder, and to make things worse, people leave and take their knowledge with them, and that is a huge risk for your project. And that's why a lot of projects end up as train wrecks, and that's something that we definitely want to avoid. So what is required to run a decent, stable, scalable, and robust data project? First of all, obviously, you need good scope and project management. You need to run a project with long-term goals, etc. That's obvious. That's the same for every project, especially data projects. But your solution needs to be easy to develop, run, debug, troubleshoot. It needs to be accessible, and you don't want to rely on a number of highly skilled, highly trained developers. That's why we talk about enabling citizen developers, people who know what the requirements are and need to be able to translate that into a technical solution without necessarily having to be a real developer. Your solution needs to be able to handle errors gracefully, to log, to monitor, to have lineage. You need to be able to test your solution. You need to be able to reproduce the same results over and over again. Lifecycle management is another important one. You need to be able to scale with your data requirements. You'll start with a small set of data, But as the requirements grow, the sources, the volume of data grows, and that all makes it more complex. And integrate with DevOps, you need to integrate with environments that are built automatically. And related, well, of course, in this case, you need to be able to integrate perfectly with Neo4j. And that's where Hop comes in. Apache Hop is what we'll have a closer look at now. Hop is a recursive acronym for Hop orchestration platform. So instead of the tools that I just mentioned in the introduction, the load CSV, APOC, etc., Hop is a platform, is not just a tool. We use some of the tools in the overview of the Neo4j tools, but Hop does a lot more. And by orchestration, we mean we process data in pipelines and workflows, where pipelines do the actual heavy lifting, where you read data from a source, do a number of manipulations, enrich, clean, join with other sources, synchronize, and finally write out to a target platform, Neo4j, or the other way around, extract from Neo4j and write to another platform. And workflows are the higher level objects that we use, where a workflow is used to check an environment, execute other workflows, child workflows, and pipelines. Hop is entirely built around metadata. We never touch any of your data directly. Everything is defined as metadata, data describing your data. And you need to have an insight of what is going on at all points in your lifecycle. So while a pipeline or a workflow runs, you need to be able to find out what is going on, how that interacts with other parts of your system. And finally, configuration is another important one. We want to have a strict separation between the code, so your workflows, pipelines, other metadata, and the configuration, the database host, username, to connect to your Neo4j servers in development, UAT, production, and other environments. The background of Neo4j. Neo4j is Apache Hop. Apache Hop is a community-led initiative. We started as a fork of Pentaho data integration over 2 years ago, and we built a community of developers that have been working, testing, trying everything in Hop since late 2019. We built a new scalable UI, a metadata backend, a simplified toolset where the GUI is supported by a number of command line tools that you can use to do the same operations, to run, configure, etc., on a headless server. And since the start, we did a huge cleanup of the entire code base and added a number of additional plugins for project and environment testing, management of your system, testing, debugging. Like I said, we forked Pentaho data integration kettle about 2 years ago. So even though Hop is a relatively new project, we have a history of 20 years of development, 20 years of adding functionality that we inherited and kept improving and innovating. We, or Hop, joined the Apache Software Foundation incubator in September last year, just over 1 year ago. And we're at a point now where we are close to graduating as an Apache top-level project. The incubator basically forces us to work the Apache way, iron out copyright issues, licensing issues, and we covered most of that, so we're getting ready to graduate. Additionally, we'll have version 1.0 out very soon, in, well, probably early October, and tomorrow is the 1st of October, so expect 1.0 soon, and that will be a major release. Everything that has been done in the last 2 years of work will be available in 1.0. We build Hop continuously, so every day there's on every commit there's a new build, but every night we run a number of tests that, well, where we eat our own dog food. We use Hop technology, we use workflows and pipelines to test our own functionality, and that has allowed us to iron out a lot of bugs and to ensure that these bugs stay fixed. So Hop 1.0 will be a robust and stable platform. We have an active and quickly growing community with hundreds of followers on the various social media accounts, and you can check everything out on hop.apache.org. Why Apache Hop? In the current data integration, data orchestration world, there are a lot of tools, there are a lot of platforms, proprietary as well as open source. But what we wanted to achieve with Hop is we wanted to have a solution for a quickly diversifying technological landscape. I don't think it's a secret that technology changes quickly, and we wanted to build a platform that integrates with legacy systems, but just as well keeps up with the complexity that comes with all of these changing technologies. And another important one is that we wanted to have that development done independently of a single large corporation. One of the reasons why we started Hop is that or Apache Hop, is that the Apache Software Foundation guarantees that no single company or organization takes control. So it's a community-led effort, and everyone who wants to contribute functionality can do so. So Hop is created by and for data orchestration professionals. The guiding principles. As mentioned earlier, Hop needs to be easy. We want it to be accessible, make sure that basically everyone can build workflows and pipelines. Needs to be fast. Your data needs to be processed as fast as possible. Transparent before, during, and after execution. You need to be able to see what is going on. Predictable, that's where we have unit and integration testing to make sure that your data not only, well, that your data processes not only run without errors, you need to be sure that the data is processed exactly the way you want it to be. Innovative, obviously. We want to integrate with the latest best-in-breed technology, and best practices is another important one. We encourage people to start working with version control, to start using testing, to integrate in CI/CD, use project and lifecycle management to make sure that the solutions people build in Hop are as good as they can be. A couple of key architecture features. We have a kernel engine, kernel architecture with plugins. Plugins are just folders that you can add or remove, and that allows us to scale back to less than 30 megabytes to run Hop in IoT scenarios on an edge device, or in cloud environments on clusters where you process petabytes of data. Hop starts in a couple of seconds, so there's minimal overhead. The combination of that pluggable architecture and fast startup allows you to run in Docker and Kubernetes in wherever you want it to be. And Apache Beam is another Apache project, obviously, that allows us to run Hop pipelines and workflows, not only on the local engine, but also run them on Apache Spark, Apache Flink, Google Dataflow, AWS EMR, other Spark instances. So that gives us a lot of flexibility. And documentation is a very important one. You need to be able to find the information about how something works, etc. So documentation is a first-class citizen in Hop. We run documentation as code. So the documentation can have bugs, can have feature requests, and need to improve with the software. And ease of use integration tests that I mentioned that before. We'll have a look at that later as well. Sorry. For the GUI, we made a flexible GUI that works with the plugins that scales on high DPI devices. Provides single click to work as fast as possible. Works on all major platforms. So we have a desktop client that works on Windows, macOS, Linux, and there's Hop Web that gives you the exact same experience on in your browser. And well, both the desktop and the web client have dark modes, because that's what you need to have. All GUI options have a command line variant, so everything is configurable from the GUI. There are no hidden configuration files, and all the actions that you can do to run, configure, etc. your system can be done from the command line as well. We have a project and lifecycle support where you define the code in your project, so your workflows and pipelines, and additionally configure environments where you have the detailed configuration, so the host names, usernames, passwords are completely separate from the code. We have a Docker container and a stateless server, version control, friendly setup, even version control from within the GUI as well. So that helps you to run Hop throughout the entire lifecycle. With 1.0 on, well, as good as available, we start looking forward to Q4 and next year. First of all, we'd like to graduate as an Apache top-level project. We'd like to have pluggable field expressions that allow you to use an expression instead of a field, instead of a hard-coded value. So you would be able to use an expression to manage your data at every point in a pipeline or workflow lifecycle. We have to upgrade to Java 11. We have to follow Apache Beam there. We need a new dialog to execute, preview, and debug, and improve cloud support. We already have support for AWS, Google Cloud, and Azure, but there's always more that we can add. We want to improve Airflow runtime support, and well, very importantly here is that we want to build a marketplace to allow third-party developers to easily make their plugins available. We already have a number of external plugins, but they need to be made more accessible. Community, like I mentioned, is very important. Great communities build great software, and actually that is one of the cornerstones of going through the Apache incubator. The two things that we need to do while in the incubator is follow the Apache way to build and release software, but especially to grow the community. And that's why we encourage people to try Hop, to play around, to join our chat, and to provide feedback to join the community, basically. Yeah, no bug is too small or too big to fix. I don't think we have been very active. We have focused on being very welcoming and have taken feedback seriously. The community is really what drives Hop forward. Going back to Neo4j and Apache Hop, it's fair to say that no other platform has the amount of support for Neo4j that Apache Hop has. In March of this year, Neo4j donated a lot of code that existed as external plugins to Apache Hop, and we now have over 20 different plugin types. We have a logging perspective where you can write execution logging for your workflows and pipelines to Neo4j, connection type, data graph type, and a lot more. We'll have a look at that in a second. And on a side note, well, there is enterprise support for Apache Hop. Open source is great, but you don't want to run an open source platform in production without any coaching, any guidance, any support. And that's where Lean with Data comes in. Lean with Data is founded by Hop developers, by Hop experts, and can help you to run Hop in production. And NoBI is a Lean with Data partner, but that's just a side note. Let's have a closer look at what Hop looks like. So this is the Hop GUI, where at the top you have your projects, a drop-down with a list of projects. Each of these projects has a one or more environments, and these environments can have a number of configuration files where you specify a number of parameter values. Yeah, I'll reload. And let me quickly create a pipeline. So the visual development that we do here is we have a number of transforms in that are available in a pipeline, and these transforms can be added on a canvas. You just connect them through these arrows that we call hops, and each of these transforms have their own dialogues to configure the properties of what these dialogues do. So in this very simple case, I generate 10 rows, add a sequence, a counter basically that will add one, that will increment with every row, and I'll save this as, and then we can run the pipeline with a local run configuration, and sorry. And once your pipeline runs, you get the metrics, how many rows were processed. You have the logging output, where, well, you have basically the logging information. And of course, your pipelines will become more complex than what we have here. And for Neo4j, the options that we have here, that we have available, are We have a Cypher input, so the result of a Cypher query will be returned as a data set that you can work with. We can generate CSV files that can be used with CSV load, so the Neo4j to CSV load. We can have graph outputs, so a model of a graph that will be loaded to Neo4j directly, import data. Neo4j output is a transform where you specify a source node, target node, and relationships, and that creates a graph as a result of your pipeline. And Neo4j split graph reads a graph as a data type and splits the graph into a list of nodes and relationships. So there's a lot of functionality there. We have an example here that is available in the samples project. And in this workflow, what we do is first of all, we do an environment check, see if we can ping the Neo4j host, then check if the Neo4j connection is available, and then we'll start loading the Belgian beer graphs. And that is a graph, the beer graph is based on a list of Belgian beers. It's an example that Neo4j's Rick van Bruggen created a while ago, and we use this to build this demo pipeline. So first we create the indexes that are required, create constraints, and then we go to the Wikipedia page that I just mentioned, get the HTML, basically do a bit of scraping here to extract the data, write that to a temporary file, and then in a second step, we read that temporary file again and use the data that we got from there to build a graph model. And in that graph model, we specify a number of brands, breweries, evaluations, period, strength, type, etc. The relationship, so the relationship between a brand and a brewery, period, brand and a strength, brand and a type, etc. Oh, sorry. And this is quite small, but this is what your graph will look like. And if we run this pipeline, takes a couple of seconds. Right, where's my browser window? Okay. So if we run this pipeline, the result that we get is a list of, the result is a graph actually. And we have the beer brands here. If you click on one of these beers, then you get the brewery, the alcohol percentage, other breweries that produce beer with the same alcohol percentage and so on. So this loads your graph in a matter of minutes, and the visual design here makes it really easy to write data to a graph, to extract data from a Neo4j database, and is a lot easier to maintain, a lot faster to develop, a lot easier to maintain, and than you would have with just code. And additionally, we have a Neo4j perspective where the logging of your graph, so the execution logging of the workflow that we just ran, is executed as a graph as well. We have the output here, there's there are no errors in this case, but there's logging. We can have a number of queries that you can execute in the Neo4j browser. So if I switch to my logging, that should be more like it. So I have the execution, an execution node here, and that node contains the contains the pipelines that were executed, other workflows pipelines that were executed. So we have the entire execution logging here, and that execution allows us to, well, do some monitoring to find patterns in how the execution of my graph, of my workflows and pipelines runs over time. This information can be combined with, for example, lineage. In this case, what we have processed is the hop code and Git logs, etc. We can additionally add AWS information here, and it gives us an entire lineage graph, for example. So we can have the link between a workflow, the commit that we had in Git, the different files that were included in that commit as well. This commit was done by Matt Casters, who wrote a lot of, wrote a lot of code. These are all of the commits that he created. But the combination of the loading of your data and the execution logging, the additional information that you can add in, through lineage, through other infrastructure items that you can add to your graph, make Hop a very useful platform to connect with and to integrate with your Neo4j data or Neo4j database. That's more or less what I wanted to cover. Are there any questions that have come up?
Yes, we do have questions. So I'll start with you, Bart. There is a question from someone that says they missed a bit there during the demo, so I'll start with that. As you were loading the beer data in, were you mapping the incoming data to a pre-known graph data model or schema, please?
Yes, in this case, in the first step, we just read the HTML, so extract the HTML from the Wikipedia page that I showed, and then clear out all the data, write that to a temporary file. And in the second step, we read that temporary file and use a graph output transform where we specify a model. So you can import a model from JSON or export an existing model from JSON. But in this case, we specify a list of nodes. So we have a brand here. A brand has a property of name. That is your primary property. We have a brewery node that has a name, an evaluation with a label property, and so on. And then we connect these nodes through relationships between brand and brewery, between brand and period, brand and strength. And that is the graph. This is basically your graph model that is generated. So we'll read the output of the first pipeline where we scraped the HTML page. and use the model that was specified here to build a graph internally and write that out to Neo4j directly. As an alternative, we could have used a Neo4j output transform, for example, where you specify a from node. So the node that that you'll start with, a second node, and then the relationship that will connect your from and to nodes. So as always with Hop, there are many ways to scan a cat. This was done in this example through a graph output, but a Neo4j output where you write two nodes and the relationships between them could have been another option.
Thank you. There is another question. Is the UI collaborative and can be run as a web service?
Collaborative in the sense that there's on the desktop GUI, there's no way to work on the same pipeline or workflow simultaneously. What we do have is Hop Web, and there's some work that we still have to do to improve in that area. But Hop Web is already usable, and you can work on, for example, your own Docker container with a Hop Web server, where you work on the same Git repository as your co-workers. So in that sense, you can collaborate. It's just not like a Google Doc where you can update the same workflow and pipeline simultaneously. But this is a bit of a different use case, different scenario.
Okay, thank you. There's another question. Is Hop designed mostly for batch pipelines, or is it suited for running continuously as well with streaming data, as known as never-ending pipelines?
Yeah. Both and hybrid. So what you can do is run in batch entirely, and that is a valid use case where you schedule workflows to run from a cron tab, from Airflow. You can also run in streaming. We have producers and consumers for a number of streaming platforms, for example, Kafka. So the consumer will continue to consume a Kafka topic. There's Google pops up, subscribe and publish over Apache Beam. So there's a variety of ways to work with streaming data, and you can do hybrid approaches as well. So work with batch and streaming at the same time. Pardon.
Okay. Another question. We have quite a few. Could you talk a bit about how to run workflows on a regular, i.e. daily basis? What would an automated setup look like? Well,
like I just mentioned, first thing you can do is use cron or any other scheduler, Windows Task Scheduler, or some other schedulers that work time-based. We already have basic integration with Airflow. Airflow, other event-driven systems could be an option as well. So scheduling is definitely an option. You can use with an operating system scheduler, third-party scheduler, with Airflow, and there are actions, for example, in a workflow where you can wait for a file, wait for SQL. So for what you typically could do there is start every hour, wait for a while to see if a file appears. As soon as that file is available, start running. So there's a combination of time and event-based scheduling that we support.
Thank you. So we have another question, but I'm going to start with another one. And I have Erman on the phone that can probably answer that one. Erman, can you hear me? Do you have use cases, examples of Neo4j usage in the utility network data, mentioning cooperation with GIS vendors?
Yes, of course. Can you hear me?
Yes, we can.
Fantastic. So my name is Herman Roelens. I'm responsible for the Benelux market for Neo4j. Yeah, and yes, we have customers. Yeah, we signed up. It's a rather new market for Neo4j since a year now. Yeah, but we signed up with Elia in Belgium. And at this moment, we are talking with all major utility companies in the Netherlands doing proof of concepts. And in those proof of concepts, we have really the need to connect GIS information into the environment. Yeah, we have some libraries that allow that, and perhaps Bart, you are also working in that space. Can you perhaps elaborate a little bit on the technical side? Yeah.
Sorry, I was reading the other question.
No, we're talking about GIS data coupled with Neo4j. Yeah, so you were working also on projects in Flanders, yeah, in the Flemish government space, and so on and so on. Yeah, so the technicality, can you please explain a little bit more?
Yeah, well, we obviously have the all of the functionality and more that I just showed. In combination with GeoGIS, there's an interesting plugin that, or set of plugins that was released just over a week ago, I think. And well, these are a set of 6 or 7 plugins that use or that enable GIS functionality in Hop, and these allow you to write out GIS information, and all of that can be used in combination with the existing functionality for Hop. So GIS support is a recent addition in Hop, but is pretty complete.
Thank you.
We have other questions. So when it comes to scalability, are you writing in parallel then to Neo4j and will encounter the same issues with locking as would any other tool would?
The issues you'll have is are the Neo4j issues, I would say. So you need to work in the transactions, etc., need to be managed. There is an option to let me check. So in the pipeline run configuration, we have an option to make this pipeline transactional, and with that option enabled, a pipeline will run as a single transaction. So that could avoid the locking issues. But again, if you need to write your data into multiple transactions to Hop, then you'll need to manage your transactions. The Neo4j, I wouldn't say limitations, but in that regard, it's probably similar to other tools. We can't implement, well, except for these transactional things, we can't avoid the safety measures, etc., that you would have with Neo4j in general. Parallel writing, by the way, is supported. What you can do is we have the specified copies, and my dialog is on a different screen. So what I can do here is increase the number of copies, and that would be the same as when I added for different outputs of that single transform, each with their own hop. So we can work in parallel, can write in parallel, but it's the target system that we want to write to that determines how the parallel streams are handled.
Okay. Hope that answers the question. So we have other questions. There's a demo one, but I'll keep it for after because it might take a few minutes. And I'll start with: is Hop equipped to perform change extraction, addition, deletion in the source if it is scheduled to run on a daily basis, or does it transfer all the data freshly again?
Could be both. Yeah, could be both. There are ways that you can do a full load, do CDC, change data capture, and even though we do support change data capture in a number of systems, what you typically would do is use a design pattern to, for example, fetch a number of IDs that are available in the target system, only retrieve the IDs that are well, that the new IDs or changed IDs from your source system, and only process that. Only process data from that was added or changed after a given timestamp. So CDC, change data capture, definitely is an option and is pretty common.
Thank you. And then, can you please give us a short demo of one way you could deploy this beer flow?
Demo is well, yeah, I don't have anything that I can deploy this to. This is a demo setup. But what we do have and what I can quickly show is we have a file explorer perspective. This is the wrong project. So let me switch. Yeah. So if I switch to the file explorer here, and we have, that was too quick. We have Git integration here. And what you can do here is, first of all, check, this is not related to deployment, but to version control. In this case, the yellow icons here identify changes in pipelines or workflows. But from this perspective, you can pull from your Git repository and then deploy on, or do a pull, a manual pull, or from a CI/CD system, and run it on a headless server in a Docker container or whatever. And the command line tools that I mentioned, I can, I'll maybe zoom in a bit. So we have a couple of tools. HopConf would set up your environment on a headless server. Hop Run is the most important one here, and you can use that to run a pipeline or a workflow. So you would need to specify an environment, a project and an environment, some optional parameters, and a run config. And with this command, well, this command is something that you could add in a cron on a server, or another option is the Docker container that we have. And well, yeah, the documentation is quite verbose, But if you push your code from a Hop project, you could use that to start a Docker container that runs a given pipeline or workflow path for a project in an environment with a couple of configuration file names. So yeah, these are two options of ways that you can run and deploy. There's no support in Hop to do the deployment automatically, except for the run configuration. So I mentioned the local run configuration that we have here. Another option is to use a Hop remote pipeline. In this example, there's a remote workflow engine as well, and that allows you to run on a Hop server. And Hop server is a lightweight web server that runs on a remote machine, and that you can use to run the pipeline or workflow instead of on your local Hop engine. Send it to the server and run it there, or in the runtime engine that server that server uses. That could be one of the Beam runtime engines as well. But that's to get into more detail on that would take us a while, I'm afraid. Thanks.